Okay, good morning all. Am I audible? And can you see the slides as well? Okay, thank you. So last time we had seen the comparison of client server with SOA, right? So today we'll be continuing with that. We have started with chapter number 4, right? We have covered the comparison of client server with SOA. Now today we'll go for the further details, right? So let us start with the next comparison. So we have seen different versions of client server last time. The first version was two-tier client server, and then we had also seen the single-tier client server. But in the next variant, the designers came up with something called multi-tier client server, right? Where the middle tier actually was designed. Right? In normal client server, you are having only two layers in the system. One is the client, and on the other side, you will be having the server, which is going to maintain your database basically. While in distributed, or you can say multi-tier client server, you will have a middle tier. So let us see how that architecture looks like. So we have on the client side, we are just having presentation logic, or you can say you will just have your HTML pages, right? That will be deployed on the client side. So that is why the client is called a semi-intelligent client, because it can do processing related to presentation logic, right? But for executing the business logic or for executing the database logic, it is dependent again. Fine. So as far as logic is concerned, we use mostly presentation related logic on the client side, and again presentation related processing is carried out on the client side. Fine. Then client is connected to the middle tier, that is known as storing of business logic, right? So last time, if you remember, we have said that client server implements the business logic in form of stored procedures. Right? While in this case, we have a separate business logic layer, and the middle tier is called application server layer, or this tier actually hosts your application server. Right? On application server, you will be installing components of your system, right? So components are nothing but collection of methods. Like you have classes as a collection of methods. So you can say components are synonyms to the packages, right? All of you have studied packages in Java, right? What is the concept of package? Yes, can you tell me what is the concept of package? Why do we create packages? Or in case of .NET, you are having namespaces or libraries. What is the purpose of all those? Yes, they define the scope at higher level, isn't it, Keval? So they are collection of sub-level details, right? Similarly, your entire logic, right? Your entire logic of the application is divided into number of components, and those components are deployed on the application server, right? So again, I repeat, the components are deployed on the application server. We also call that as an app server, right? So that is this middle tier. Fine. It is not necessary that you will have only one server, right? You might have more than one servers if there are too many components, right? So actually the middle tier, we cannot say it is only one layer, right? There can be 1 to n, and that is why this architecture is known as multi-tier. Middle tier can be expanded into any number of layers depending upon the complexity. So are you clear up to the middle tier? Right? The middle tier, we are having semi-intelligent application server where the components are stored, okay, and a lot of processing is carried out on this side. Yes, is that fine for this? Can we go for the next year? Okay, okay. Then on the right hand side, what you see is again a pure database layer, right? So you have a database server where your data related processing will be carried out. Okay. So your request will be first starting from the client side. It will go to the middle tier, that is app server, and app server will be redirecting that request to the data server, right, or database server. And again, the response comes back, right? So we are having some kind of navigation over here, right? For every request, you have to pass through this paths, right? Okay. So in this case, what is still the problem? Can anyone tell me what is still the drawback of this design, multi-tier client server? Or in other words, can we still simplify this? Yes. Okay, I'll add one more question to that list. If internet is available, assume that internet is available, can we further simplify this design? This was the era where internet was not available. In that case, you were connected to the server, right, over the local network basically. Right? So if internet is available, which layer will be changed? First, second, or third? Or which tier will change? You can also answer with multiple options, that is 1 and 2, or 2 and 3, and so on. Yes. Any guesses on that? Okay, let me go through that. So if I add internet over here, then on the client side, what we require is just a browser, isn't it? Do you agree to this, please? On the client side, if internet is available, what I require is a browser only. Yes or no? Right? I don't have to install my application on the client machine. Right? Clients can access my system just by using the browser. Yes, are you getting the idea what I'm trying to describe? Yes. Shahid Kewal. And those who are replying, yes, Janil. Okay, okay. So remember, this was called multi-tier client server. If I introduce one more feature, that is internet, now it becomes distributed internet architecture, right? And that is in short called DIA, right? Distributed internet architecture. Fine. Just observe this. We'll compare this with the previous one. In this case, on the client side, we are just having browser, and that's why it is called again a dumb client, right? You can access any application all over the world, right, through the use of the browser. No logic will be installed on the client side, right? It is just rendering the pages, that's it. Okay, so only presentation related processing is there on the client side. Okay. In the middle tier, the complexity increases because in the middle tier, you have to combine the presentation logic and business logic. Okay. And due to that, we can subdivide the middle tier in two parts. So the middle tier is split into two parts. The first of that is your application server, and the second is your web server. Right? Because ultimately, whatever component you are having, right, they will be hosted on the web. Okay. And that is why the middle tier is a combination of two types of servers. One is app server and the other is web server. Okay. So obviously, there is a lot of processing we have to do, right, in the middle tier. Now, if you go to the right hand side, on the right hand side, we are just having data logic, right? So you are having database related processing and data related logic. Fine. So if you just compare this architecture with the previous one, which is more efficient? Multi-tier client server or DIA? Yes. Which seems correct solution or which is a more appropriate solution, in other words? Multi-tier client server, which you can see over here, and distributed internet architecture. You can just type in one or two, right? One, I mean, for multi-tier, and the second is for distributed. See, again, in this case, middle tier has to do a lot of processing because all the components are there on the middle tier. Plus, you have to manage the web as well. Fine. So yes, there is a lot of complexity, but the client side is simplified. Do you agree with this? Yes. Abhi, Keval, Janil, Shail, those who replied earlier, and others also. Okay. Thank you, Shail, for the reply. So this seems to be the correct solution or better solution, and that is why this is the architecture we would like to compare with SOA, right? Because this architecture can evolve, or we can make the changes in this architecture to convert it into SOA, right? So that is possible. So we should be able to compare. If someone gives you the architectural design of any system, and if you are asked that find out what type of architecture it is, so you should be able to distinguish whether it is DIA or it is an SOA, right? So that question we need to answer, right? That is why we are doing all this exercise. Fine. Okay. So comparing SOA with distributed architecture is actually a contradiction because SOA is actually one style, or I would say one type of DIA only, right? SOA is one way of having distributed computing, right? But what we are trying to compare over here is the historical distributed architecture, that is this. Right? Nowadays, it is very difficult to find out the differences between SOA and DIA because SOA is actually one style of or one subcategory of DIA only, right? But still, we'll try to compare and we'll see what are the similarities and what are the differences. Right? There will be some similarities, there will be some differences. Okay. And I'll be comparing it according to 5 points. The first is application logic. So how the logic is divided in your application and what kind of communication you are supporting in the application, right? The second criteria for comparison is application processing. Okay. So how your applications execute in SOA or in DIA. Okay. The third will be comparing with the technology. So what kind of technology you are using in service-oriented architecture and what kind of technology you are using in distributed architecture, right? Fourth option that we'll be seeing will be according to the security. Right? So what level of security we require. Right? And then the last is administration. So what kind of challenges we face to manage SOA and what kind of challenges we face to manage DDI. Okay, so let us begin with the comparison. So the first question is regarding the application logic. Let us read the question. Where the partition units of logic reside. That means ultimately I'm dividing my logic into components. I'm not keeping my logic as a single component, right? I'm dividing my logic into multiple components, fine? So where those components will be residing for DIA or SOA? Actually, this is a similar point, right? Because in both the cases, in SOA as well as DIA, right, the components are residing on servers, right? It may be residing on the application server. If it is a web application, it will be residing on the web server, right? But where is the difference? Difference lies how the application logic is actually divided and how or what kind of communication is supported. Fine. If you observe this slide, we have seen that in distributed architecture, it is called synchronous communication. Can anyone tell me synchronous communication and what will be drawback of that kind of thing? Yes, synchronous is basically request and reply kind of behavior. So until reply comes back, right? Until the reply comes back, request is going to be blocked. Requester is going to be blocked. Yes, exactly. So can I say that there is high amount of coupling in this design? Because you are not free to do anything else if you want, right? You will be blocked. Can I say that it is going to increase the amount of coupling, right? So that was the basic problem, right? Because it only supported synchronous communication. Right? So like this, we have to compare. Right? This is one example of comparison point. Okay. So how application logic is divided, that is first difference, and then how it allows communication. That we'll answer in the next slide. Okay. In both the cases, we focus on reuse. So again, this is a common point. As I said, SOA and DI have some common things, some different things. Okay, so we'll try to find out both. Reusability is common for both, right? But in SOA, we are having more reusability because we can design such services which can be consumed across different platforms, right? Like in WCF, can you consume a WCF service using a Java client? Is it possible? Yes, I think Sir has covered that part in theory also. Can you consume a WCF service using Java client? In other words, is WCF service interoperable? You must have seen a table where Sir might have shown you that some bindings are interoperable bindings. Have you seen that concept? It is, remember that point? Interoperable means you can communicate with different platforms, right? So that is the main feature of SOA, while that is not usually possible in case of distributed architecture. Okay, so let us go for the next slide where we have this, how the application logic is divided and how it allows communication. Okay, so I'll go point by point now. So let us start with DIA. In case of DIA, components are residing on one or more servers, right? Same way, we can say for SOA, SOA relies on components. They are also stored on different servers. But what is the difference? In SOA, we use services, right? And services cover the components, right? Or you can say services act as an encapsulation mechanism that covers the components, right? Or they hide the components, in other words. Okay, so that is the first difference. You are having components in both the cases, right? But in DIA, the components are exposed directly, while in SOA, we use web services, right, in a standard manner. Okay, now the second difference is DIA is designed with varying degree of granularity, right? I gave you the example of fine grain and coarse grain last time, right? Does anyone remember regarding that? Fine grain means you are sending just a small amount of data, or you are representing small amount of data. Right. While coarse grain means you are representing a collection of data. Like if you are sending a single parameter and if you are sending a complete object, which is a coarse grain kind of design. Yes. If you are designing a single function, or if you are designing, let us say if a function takes just an integer parameter and the second one takes an object. Which one is more coarse grain? First or second? Which gives you more amount of data? Object, definitely, right? Because object can give you a collection of data, right? It encapsulates your data. So in case of DIA, they were using different granularity. That means some components were fine grained, some components were fine grained, and the other components were coarse grained, right? But what do we usually prefer in SOA is, if you remember that term, we have seen that in last class, document style message. We generate document style message. That means we generate a lot of data in a single message itself, right? So usually, whatever operations that you are designing in an SOA application is going to be a coarse grain application or coarse grain interface. So this is the second point. In DIA, you will be having a mix of grain system. You might be having some fine grain operations, some grain operations. While in case of SOA, we are using principles of service orientation, and mostly the components will be coarse grain, right? Third difference, same server components communicate using proprietary APIs, right? So this is again a problem. If you are having two app servers, or let us say if you are having one app server, and that one app server is having 10 components, right? One app server is having 10 components, right? So if component 1 wants to talk to component 3, let us say your logic is like that, component 1 talk to component 3, it won't be using the standard protocol, it will be using the proprietary protocol like RPC based mechanism, or it might be using the protocols like Corba or DCOM, right? Fine. So these are the examples of proprietary protocols. That means they are supported by only a few programming languages, or you can say a single programming language. Generally, the Corba is used by Java, right? So when you use proprietary protocol, can you communicate with different platform application then? Where you're using internally proprietary communication, can you talk with any platform application in the system? Are you getting the question? Yes, if you are using proprietary standard or you are using global standard, what is better? Use of global standard is better or use of proprietary is better? Obviously, global is better, right? Because that is going to provide you interoperability. In case of DIA, that was not possible, right? So in SOA, what do we have? In SOA, we use standard interface mechanism, right? And it can expose either the legacy application or non-legacy application. This we have seen, right? We designed the adapter services. And adapter services will be taking the request from legacy application, and then it will be shared with the actual application. Fine. So in SOA, everything is generalized, or we can say that we are using global protocols for communication. Fine. So that's why it is beneficial. Okay. Next point. In DIA, actual references are embedded in the code. That means you will have hard coding of addresses. URLs of the components which you want to call are embedded in the code, right? Now, when you are embedding the URLs, right, what will be the basic problem that will take place? I'm hard coding that I'll be calling this component under this situation. What is the problem due to that? Can I say that dependency is going to increase or coupling is going to increase? Yes, right? So that is again a problem. You are embedding the actual references in the code itself, which is not a good design. In SOA, in opposite to that, what do we use is we use discovery mechanism, right? We get the WSDL file, right, from UDDI, and then we are able to communicate with the service, right? So you can say that we are using loose coupling. We don't connect to the service directly. First, we go to UDDI, then we fetch the WSDL file, and then you are able to get that information. Yesterday only, when you write that when you wrote that calculator application, you must have added that service reference, right? Did you add that? Yes or no? So why we are adding service reference? Can anyone tell me? You must have clicked that discover button, right? Discover button to get that information from the service. Did you use that in lab yesterday? Yes, exactly. To get metadata, exactly, right? So that was the step actually, which we call as loose coupling, because you are not connecting to the HTTP endpoint directly, right? We are connecting to the MAX endpoint by adding the service reference, and through MAX endpoint we will get the WSDL file, okay? And that WSDL file is stored on the client side. Did you try to open that WSDL file as per the screenshot? Anyone? The WSDL file will be downloaded after you add the service reference. Is that concept getting clear? Once you add service reference, when you click on discover button, in background your WSDL will be downloaded. Are you getting this concept? Yes, you should be able to relate the theory with practical, right? Otherwise, there is no purpose of studying all these things, right? So you should always be able to relate. Okay. If you have not opened the WSDL file, do it today, right? Whenever you are free, and just have a look at that WSDL. Is it structured as per what we have seen? Right? Just go through that once. Okay. So in SOA, I'll come back to this slide. We use discovery mechanism. So we first exchange the metadata and then we connect to the service. That is the ideal situation. Fine. That is the fourth point of comparison. Then for intra-server communication, we rely on RPC. Intra-server means across, or you can say between different servers. Between different servers, we were relying on RPC. And RPC has a major problem, right? RPC cannot pass bulk of data. It cannot pass bulk of data. That means if you want to fetch a lot of information, you need to pass multiple requests, right? So basically you will be passing fine-grained information if you are using RPC, right? Rather than that, it's better to use document-style messages, which we use in SOA, so that we can pass bulk of data, right? That is another benefit. Okay, so that is the next comparison, that services rely on the document-style messages, which contain lot of information. So are you clear up to this first comparison point? Yes. How application logic is divided and how we communicate. Okay, we have covered these two aspects. Now we are going towards application processing. So how your logic actually executes, right, in both the cases, DIA or SOA. In DIA, we rely on proprietary protocols. So for communication, we don't use global protocols. You focus on the protocols supported by only one framework. Let us say it is a Java-based framework or .NET-based framework, right? So mostly they were using DCOM or Corba, right? Mostly they were supported by Java, right? Large companies use DIA. Yes, if you have a large solution, it must have a DIA, right? Obviously, but DIA has problems, right? So I would recommend that if they are using DIA, they should move to SOA as soon as possible, because of all the advantages which we are seeing, right? So that is a transition happening currently, right? Whoever is using DIA, pure DIA, or you can say old version, are actually moving to SOA, right? And that transition you should know, right? So if you are given a task to convert a DIA, old DIA system into the latest SOA design, you should know all these points. That's why we are taking time on this comparison, right? Okay. So first point, we are using proprietary communication protocols. For SOA, we use message-based communication or standard communication, right? But remember, when you are doing something which is generic, it is going to involve overhead, right? We are going to do serialization and deserialization, right? So whenever, I think yesterday only you coded that calculator, right? So you have to pass the integer values to integers, right? But are you passing integers as integers only to the service, or you are converting them to some other format? Yes, you must have seen that when the SOAP message gets generated. Are you converting integers to some other format? Converting to XML, isn't it? The integer has to be converted to XML. And when the service receives that, what it has to do? XML to integer again? Yes or no? XML to integer, right? So on both the sides, we require conversion, right? So there is an overhead, right? This is called serialization, deserialization. Converting from one format to the XML is called serialization, and from XML to other format is deserialization. This has to be done for every SOAP message. Remember, right? We are sending a lot of messages, right? So relying on message-based communication is good, but there is overhead. Fine. We also have to do validation, right? For validation, you have seen two types, right? DTD and schema or XSD. So you might also have to perform validation of your parameters data types by looking at the XSD schema, right? You also have to do parsing, right? Parsing the XML, right? So all these things have to be done, right? But by doing this, what is the advantage we are getting? As we are using standardized communication, we can talk with multiple types of applications. That is the benefit. Okay. Clear with the first point? Proprietary versus global? Yes? Understood, all of you? Okay. Now, second point. In DIA, we usually require active connection. Why active connection? Because we are using synchronous communication, right? We are using synchronous communication, and that is why you have to open a connection and remain active until the reply comes, right? And when you remain active for a long time, there are two problems. First is you are not available, right? You are not available for other services, right? As well as you are being stateful. Did you understand these 2 points? When we say I'm not available, that means the reusability will reduce, right? You will be able to handle less number of requests. Plus, you are remaining stateful. And if you remain stateful, the coupling will increase. Are you following this? Yes? Okay. So, in case of DIA, this is again a major problem. Although it supports stateless components also, but mostly the design is stateful, right? I would say 80% of the components will be stateful, right? And we support synchronous data exchange. Fine. While in case of SOA, we use stateless services and they are autonomous, so they are not dependent on each other. Plus, we have asynchronous communication. Fine. So this is also beneficial because when we are being asynchronous, that means after sending the message, service is available. Once again, is this clear? What I'm trying to compare is clear. Yes, so which is going to be providing more flexibility in this comparison, SOA or DIA? Which architecture gives you more flexibility, more independence? Yes, it is SOA again, right? Good. So this is about how your logic executes. Okay, we have covered the second point. Let us now go for the third point. Third point is regarding the technology. Over here, there are very few differences because in DIA also we can use web services, we can use HTML, we can use XML, right? So actually there is not much of a difference, right? The difference lies where? The difference lies because in case of SOA or in contemporary SOA, I have written that the CSOA over here. XML is the base, right? Everything is based on XML. Yesterday you have seen that, right? When you implement WCF services, everything gets converted to XML and then you have to process that XML and so on, right? In case of DIA, XML and use of web services, both are optional. It is not compulsory that we have to use web services always or we have to use XML, right? In SOA, we mostly rely on web services and XML is always a part. Right? So as a technology, as far as technology is concerned, the difference is in SOA, XML comes as a default, while in DIA, XML is optional. The rest, everything is common. Understood this slide? Technology-based difference? Yes, all of you are clear? Okay. Fine. What is the next point? Let us go for the next point, security. In security, if you compare again, in DIA, we use proprietary mechanisms. Right? Again, we rely on proprietary mechanisms. And when I say proprietary, that means programmers have to handle the security logic themselves, or they might have to rely on the platform. If you're using .NET platform, then you might have to use some .NET-based security standards. Sorry, .NET. Right? Or if you're using Java-based application, you need to rely on the Java-based technology for providing you the security. Right? So there are multiple techniques available. Delegation is available. Impersonation is available. Right? Encryption. I'm not going in detail right now because these are in proprietary techniques. While in SOA, we use a standardized framework that is known as WS Security. WS Security is capable enough to work with any client, any type of service. Right? So that is again a benefit. Okay. Instead of using proprietary, we use standard. Okay. So that is the difference over here. WS Security can ensure that your SOAP message is encrypted entirely, right? Or if you want to encrypt your SOAP header, it is also possible. If you want to encrypt only the SOAP body, that is also possible, right? So you can actually customize what you want to encrypt, right? So that is how we handle it. Okay. Next, we compare the administration aspect, right? So in case of administration, distributed architecture keeps track of component instances, right? As there are multiple components, right? So you might be creating multiple instances. It is just like we create object for classes. We all know, right? Object is instance of a class, right? Similarly, for the same component, there can be multiple instances because there might be 2 or 3 clients connected to the same service, okay, connected to the same component. So in that case, we will be actually keeping track of multiple instances, right? And you also keep track of consistency of your data as you are sharing the same component with multiple clients, okay? You also have to keep track of local and remote problems. What do you mean by local problems? Yes, can you tell me? What is the example of local problem? Yes. Local problem means these problems are occurring at the client side, right? And the remote problem means the problem occurring on the server side, right? So we have to keep track of both kind of issues, and we should be able to find the solutions to both the issues, right? So that is the concept of local and remote problem tracking. Then we have to monitor the server demands, right? That means the server should not be loaded with too many requests, right? So that also we have to keep track of. Database administration is always obvious, right? When you are having a large scale solution, right? Scalability of web servers is again an issue. So if your web server cannot handle more than 500 requests, right? So you need to take care, right, of management of the requests, right? That is about scalability. In SOA, we say that all previous problems are also present. That means we have to keep track of service instances, not component, but service instances. We also have to keep track of local, or you can say the services which are on the local server, the services which are there on the global server, right, and so on. We have to keep track of server demands, database administration, plus scalability. So these five aspects are also required for SOA. Plus, we have to do runtime administration, because in SOA we are relying on loosely coupled communication. So most issues will occur at runtime. Remember, most issues will occur at runtime. So you should be able to handle those runtime issues. Right? What if a message is delivered to wrong destination, right? Or a message is not delivered, right? As you are loosely coupled, you will never know whether the message is delivered or not, right? So this kind of issues can occur. Okay. Then we may also have messaging framework problems. As I said, your message might be lost, right? Okay, so third is maturity of WS extension. For example, someone has designed a very good security framework. And it has been accepted as a standard, let's say, right? Someone has designed a very good security framework. It has become a standard since 2 years. Right? And on the other side, you are also having an option of WS security, which has been around, for example, I'm saying since 10 years. Which one you trust in? The latest one or the one which has been in existence since long time? WS security, because it must have been tested thoroughly, right? It has been in market since a long time. Okay, so that is the advantage, right? We need to decide the maturity of extension, how old the standard you are having, right? Because if it is still new, it might be being tested simultaneously. That need to take care of. Okay, so this is about administration. Some things are common, some things are different. I hope you're getting the point, right? I'm not clearly comparing two architectures, because SOA is a type of DIA. Some things are going to be common, but we need to know what is the difference. Okay. So this is about SOA versus DIA. Now let us look at one more diagram. Right? This is called hybrid web service architecture. Hybrid web service architecture. In earlier days, what people used to do was, as DIA had some issues, right? So what they did was, DIA made use of web services. Or in other words, if I say the components used in VIA were encapsulated by web services, and then the services were given to the customers or the clients for consuming purpose, right? So in this case, web services were actually acting as wrappers, or you can say adapters in one sense. Okay, they were encapsulating the components, right? You can see that in the example. This first web service on the left hand side is encapsulating the first and second components. The second web service is encapsulating the third and fourth component, and so on, right? But what is the problem with this kind of design? When you are just designing wrappers, can we say that we are dividing the logic once again in this situation? Or are we just doing wrapping up operation? Yes, I'll again repeat the question. Can I say that I'm going to rewrite the components so that they become web services? Or I'm just wrapping up existing components as they are? What are we doing? First or second? Wrapping up. And when you are wrapping up, you are ignoring how the components are designed, isn't it? You are ignoring how the components are designed. Yes. So components might be not properly designed. They might be using proprietary communication protocols, right? So all the problems of DIA will still remain. Yes or no? All the problems of DIA will still remain. Right? What is the only advantage we are getting? We can use web services and we can use SOAP messages if required. Okay. Can I say that this is pure SOA? Or can we even classify that this is SOA? Can we classify that this is SOA? No. Right? And that is why the name of this architecture is what? Hybrid web service architecture. Hybrid web service architecture. All of you are following this? I think Shail is able to understand about others. Yes, Abhi, Janil. Yes, yes. Okay, okay. Harsh, yes. Okay, okay. So, see, why are we comparing this architecture? The reason is you should be able to differentiate whenever you look at any architecture diagram, right? Is it client server? Is it distributed architecture? Is it multi-tier client server, right? Or is it hybrid web service, right? So that should be clear in your mind. That is why we are taking a lot of time on this. Okay. So this is not, you can say, pure SOA, right? So that is written in the next slide. Let us look at that theory now. So hybrid web service architecture does not qualify a true SOA. Why? Because the logic is not partitioned properly. That means we are not following principles of SOA. We are not following principles of SOA for dividing the logic, right? That is one point. Second is we are having point-to-point connection. So what you can see over here, these SOAP messages are actually statically binding one web service to the other. These are not dynamic messages. Right? So there again, the problem of coupling is going to take place. Right? Problem of coupling is going to take place. Fine. So that's why it is known as point-to-point connection. While in case of SOA, we don't use one style of messaging. That means we don't use proprietary communication. We use standard messaging models like SOAP. We divide the logic properly based on the principles so that your services are loosely coupled, they are autonomous, right? They are stateless and so on, right? And we are never limited to point to point. Right? We use point to star communication, if you remember that, right? Point to star. Point to star means your request can be processed by any number of services in between, or we call that as intermediate services. Right? So that is the first point. Okay. Okay. So let us summarize how many architectures we have compared up till now. SO versus two-tier client server. Right? What is the basic difference in two tier? In two tier, we are having client side and database server. Client side and database server. While in SOA, we are having the logic properly distributed in services. Right. The second is SOA versus distributed architecture. Right. And the third difference that we have seen is SOA versus hybrid web service architecture. Okay, so are you clear with these three comparisons? Yes. So in history, there have been four basic architectures, and that's what we have tried to compare point to point. Okay. I hope all of you are clear. Only Sheila is replied, but I think the others who are listening are also clear, right? Okay. Okay. Thank you, Harsh. Fine. So now we'll look at the other aspects. Right? Next comparison which I'm going to make is actually service orientation and object orientation. Right? So it is not versus. Right? Because ultimately, how you are implementing the services, even in WCF or even when you will learn Web API, what is the programming language or programming style you are going to use? Yes, it will be object orientation, right? So it is not actually a comparison, it is just a relationship which we'll try to establish, right? So that is the next point in this chapter, service orientation and object orientation, right? So as we know, object-oriented programming is commonly used to build the applications for service-oriented architecture, right? But fundamentally, there are some differences. Right? For example, if I give you one question, let us see whether you can answer or not. If I say that object is stateful by nature, and if I say that object is stateless by nature, which is correct? First or second? Think about object, right? Not a class. Object is stateful or stateless? When you are handling one object at a time, can I say that it is stateful in nature? Yes, any guesses? See, object encapsulates your data and behavior, right? So it is binding it together. And when you are binding something, you are actually remaining stateful, or you are trying to be stateful. Do you agree? Yes or no? Right? So the first statement is correct. Object by default is stateful, but the contradiction is same object we are able to use to implement services to maintain statelessness. Are you getting the contradiction? Yes? We are using the object-oriented programming, right, to implement service-oriented applications, right? So yes, you are using stateful objects, but you are using stateful messages in this way, and that's why you are able to achieve the complete statelessness, right? So this kind of comparison we are going to do. This was one example, right? So let us start. First point is this. In service orientation, our focus for using stateless service is stateful object. That's correct. Because object by default is stateful. That is the essence of object-oriented programming. Right? Yes? Yeah. But as we are making the messages stateful, as we are storing the state information in the message, that due to that, your services can be stateless. Right? So services are stateless, while you can say that your messages are stateful. That is the relation. because we are embedding a lot of intelligent information in this message, and that's why messages are stateful, you can say, right? If messages were not supposed to be stateful, then there was no option. You have to make your services stateful, right? Okay. So let us start with the first point. Service orientation is focusing on the service design, while object orientation focuses on the object design. Very obvious point, right? Service orientation emphasizes loose coupling between services, obviously, because otherwise we'll have a coupled solution. While object orientation is based on objects, while objects are inherently tightly bound to each other, right? When one class or when one object, right? In other words, you are calling one method of the other class, right? In that case, you are actually binding yourself to that class, right? Let us say customer class is invoking a method of order class, right? So you are binding yourself to the order, isn't it? Yes. And same we draw in the class diagram, right? Same we draw in the class diagram. Okay. So it is altogether different, but still we are able to achieve loose coupling, right? That is a contradiction. Okay, let us look at the next point. Scope of unit of processing logic is variable in case of service orientation. In other words, you can design services with 2 operations, or can design services with 10 operations. In first case, my scope is less because I'm having only 2 operations. In second case, my scope is more because I'm having 10 operations, right? While what do we say about object? Objects are always smaller in scope. Do you agree? Every object is targeting only one entity at a time, right? So the scope of object is limited, right? So that is the third comparison point. Are you clear with these 3 points, although I have not labeled them, right? First point is regarding focus. Our focus in service orientation is regarding services. Our focus in object orientation is regarding the objects. Okay. Second point, service orientation focuses on loose coupling between services. Object orientation also tries to achieve loose coupling, but by default, you will be connected to some or other class. You will be connected to some or other class. We cannot have a class diagram where all the classes are hanging, or you can say they are not connected. Okay, it is not possible to have such a class diagram. Fine. The third is the scope of service logic can vary. You can have a service having only 2 operations. You can have a service having 10 operations. While in case of object orientation, the scope of object is limited, right? Why we are comparing this? Because in SOA, unit of logic is a service. Unit of logic is a service, while in object orientation, unit of logic is an object. Okay. Let us cover one more point, then I will stop. Next point is service orientation prefers units of logic, that means services. Service orientation prefers services to be as stateless as possible, right? We would try to make services as stateless as possible so that our messages are stateful, right? In case of object orientation, object binds data and logic together. Data means variables, logic means methods. Hence, it tends to be stateful. Hence, it tends to be stateful. All of you are clear with this point? Yes, we already discussed, right? Objects are stateful, right? While services are stateless. Okay. It's already about time, so I'm ending over here. We'll continue from this comparison in next class. Okay. Let us end the session. Have a good day.
Hello everyone.